4.1 Inverse functions. So we're just going to do a basic overview of inverse functions. So first I'm going to give you a picture, and I need you to tell me if the function is what we call 1 to 1. Okay, 1 to 1, if a function is 1 to 1, then it has an inverse. If it's not 1 to 1, then it does not have an inverse. So if you were to have our parabola, okay, and I'm just doing a sketch. To determine if a picture is 1 to 1, you're going to do the opposite type of test from when it was a function. When we talked about functions in 2.3, to determine if something was a function, you did the vertical line test, which is the pencil test. You would draw a vertical line. If it hits the picture one time, then it was a function. Now, to determine if it's 1 to 1, we're going to do the horizontal line test. And if you see, that horizontal line hits your picture in 2 places. So if it hits in 2 places, then it is not 1 to 1. So that means that the parabola doesn't have an inverse. And I kind of said that earlier, but I kind of want to reiterate this is the reason why. It does not pass that 1 to 1 test. Okay? Let's look at another picture. What about our cubing function? So again, if we were going to do the horizontal line test, doesn't matter where you do that horizontal line, it's only going to hit your picture one time. So determining if it's 1 to 1, you would say yes. This picture passes the 1 to 1 test because it only hits one time. If it hits more than one time going horizontally, then it's not 1 to 1, which means it does not have an inverse. This has an inverse, and we know that to be the cube root function. And let's look at one more picture, and I'm just going to do a random squiggly line. It's not really a line, but a squiggly. And if we did that horizontal line test, you see that it will hit in multiple places. So this is not 1 to 1, which means it doesn't have an inverse. So if I give you a picture, I would hope that you could determine if it was 1 to 1, meaning it would have an inverse by doing the horizontal line test. If it was to hit your picture in one location, then it is 1 to 1, which means it has an inverse. If it hits in more than one location, it is not 1 to 1, which means it does not have an inverse. Next, let's look at some T-charts. We're going to decide whether the given functions are inverses. So, if I give you a T-chart and we got x and f of x just means y. We have 3 and negative 4, 2 and negative 6, 5 and 8, 1, 9, 4, 3. And then we have the g function, which again just means y. And we have -4, 3, -6, 2, 8, 5, 9, 1, 3, 4. Now I'm asking you if these two functions are inverses. This being the f function and this one is the g function. Now, if you notice, they are reversed as far as my ordered pairs. I have 3, -4. I have -4, 3. I have 2, -6, -6, 2. 5, 8, 8, 5, 1, 9, 9, 1, 4, 3, 3, 4. Yes, they are inverses because they are completely switched, okay? In order for them to be inverses, x and y have to switch places. So in the f function, where I have x, that's now the y numbers in the g function. And the same for the x in the g function is now the y in the f function. No signs are changed. They just completely switch places. So you see that they are completely switched. So yes, they are functions. Giving you a second set of t-charts. -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Oops. We got 8, -2, 1, -1, 0, 0, -1, 1, -8, +2. You have to excuse my handwriting. But if you look at these two t-charts for the f function and the g function, you will see that they are not the same numbers. I have -2 and -8, but then I have +8, ding, 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 -2. I must have a negative on that 8 for it to be switched. You can't change the signs. Even on the second one, you must have that negative on that 1. So these are not inverses because my signs are different. In order for them to be inverses, yes, they have to switch places, but the signs do not change. So they are not inverses. Okay? So I would hope that you can be able to tell from two t-charts if they are inverses or not. Next, we're going to determine if f and g are inverses. So we have f of x equals 2x plus 4. G of x equals 1/2 x minus 2. Now you can do this multiple ways, but I want to show you how to switch between x and y to determine if f of x is a function, inverse of g of x. So we know that f of x means y. And I'm only going to use the first function. Okay, so you don't have to reconstruct both of them. Just pick one. I'm going to do the first one. And we know f of x means y equals 2x plus 4. So I'm going to switch places. That's what we did with the t-charts. I'm going to switch places with x and y. So I'm going to have x equals 2y plus 4. And I'm going to solve for my y in its new location. So if I solve for y, get it by itself, I'm going to subtract 4 to the other side. And then I'm going to divide everybody by 2 to get it off of my y. So that will leave me with 1/2 x minus negative 4 divided by 2 is that negative 2 equals y. Then I'm going to look at my g function. Do they match? 1/2 x minus 2, 1/2 x minus 2. They match, so yes, they are inverses. Okay? That's the easiest way. I would switch places with x and y, and then solve for the y, and see if it matches what g function says. Let's do another one. F of x equals negative 3x plus 12, and g of x equals negative 1/3 x minus 12. So we know this is y. F of x means y. And in the place of x and y, we're going to switch them. I'm going to have x equals negative 3y plus 12. And then solve. Solve for y in this place. So we're going to subtract 12. So it'll be x minus 12 equals a negative 3y. Then we're going to divide everybody by negative 3. So that would give us a negative 1/3 x. Negative 12 divided by negative 3 is a positive 4 equals y. Then we look at the g function. Negative 1/3 x plus 4, negative 1/3 x minus 12. They don't match. So not inverses. They're not inverses because they don't match. Next example, f of x equals x to the third plus 1. G of x equals the cube root of x minus 1. So again, we know that f of x means y. And I'm going to switch places. With my x and my y. So I'm going to have x equals y to the third plus 1. And I'm going to solve for y in its new place. So I'm going to subtract 1. And then in order to get rid of the cube, I take the cube root. So that's going to give me the cube root of x minus 1 equals y. And I look, they match. So yes, they're inverses. Next, it says, if the function is 1 to 1, find the inverse. Okay. So if you were to have a group of ordered pairs, negative 3, 6, 2, 1, 5, 8. And you're going to say, if the function is 1 to 1. Now, keep in mind, when we did functions, we couldn't let our x repeat. Okay? Now, this is going to be the reverse. You can't let y repeat if we're talking about 1 to 1. So, we're going to focus on the y numbers. And you see they're different numbers. 6, 1, 8, nobody's repeated. So, yes, this thing is 1 to 1. I shouldn't say yes, inverse. Let's say yes, it's 1 to 1. Which means it has an inverse. So, since it's 1 to 1, they want you to give the inverse. The inverse would simply be me switching x and y. So I would have 6, negative 3 for the first pair, 1, 2 for the second pair, and 8, 5 for the third pair. That would be the inverse. Keep in mind to do the inverse with ordered pairs, kind of like that T-chart. You just switch your x and your y's. So what if you had the ordered pairs 1, negative 3, 2, negative 7, 4, negative 3, and 5, negative 5? Would they be 1 to 1? Well, the answer would be no, because in the y spot, your 3 is repeating. Negative 3 is repeating. So this one would be not 1 to 1, which means it doesn't have an inverse. That would conclude 4.1.